Hello everyone, my name is Amaya Nanayakkara. Currently I am a final year student in National Institute of Technology, Rourkela. I have done an IoT internship in Emertxe Information Technologies. As a part of the internship, I have assigned to do this project, which is IoT based home automation solution. First, let's see this PPT and then I'll show you the demonstration of the project. The contents of the PPT are topics learned during internship, what is a home automation system, software and hardware used, project requirements, and finally, project implementation. Let's move to the first content, topics learned during internship. The main topics that we covered in C language are basic syntax, data types, conditional constructs, operators, arrays and pointers, functions, recursion const qualifier, strings, storage classes, preprocessors such as header files, macros. The few topics were covered under C++ language, that are basic syntax, class, object creation, constructors and destructors. Now, an introduction to embedded systems. Embedded system is a microprocessor-based computer hardware system with software that is designed to perform a dedicated function either as an independent system or as a part of a large system. Microwave oven, washing machine are some examples of these. Based on the performance and functional requirements, we can classify embedded systems into four categories. They are standalone embedded systems, network embedded system, real-time embedded system, which has two parts like soft and hard real-time embedded systems, and the last one, mobile embedded systems. Let's move to the next topic. Introduction to IoT. It describes that the physical objects or group of such objects with sensors, processing ability, software and other technologies that connect and exchange data with other devices and systems over the internet or other communication networks. Few of the examples of IoT would be smart home system, activity trackers, motion detectors and much more. There are so many advantages of IoT. It's important to generate new business models and revenue streams. It increases the productivity and efficiency of business operations, and it improves business decisions through data-driven insights from IoT data, and also enhance the customer experience and many more. Now let's find out what is a home automation system. A home automation system is a network of hardware, communication and electronic interfaces that work to integrate devices with one another via internet. We can manage those devices using our smartphones, tablets, whether we are at home or not. Talking about the benefits of this IoT-based solution, it provides remote access and it's comfortable and convenience, and increased safety, and it's an energy efficient solution. Talking of the disadvantages, it depends on the internet. Whenever there is no internet, we have to face issues. Not only that, but also it is dependent on professionals. Whenever there is a problem, we need to seek help from professions. And also, the cost is also higher as it uses so many costly equipments. Now let's move to the software and hardware that we used in the project. As this is an online internship, we couldn't use hardware. So for that we used PICSIMLAB software. Here we can use our hardware components. First one is Arduino IDE. This is the development environment of our project. Here we write our required code and compile it in order to implement our project work. The next one is PICSIMLAB software. It's a real-time emulator and it supports several devices that can be connected to the boards for the simulation process. This is the simulating tool of our project and we execute and see the output here. Not only that, but also we use null emulator, which is the virtual serial connection in order to do the serial communication between Arduino IDE and PICSIMLAB. Next one is Blynk IoT app. This is the mobile application that we use to control the activities using our smartphone or tablets. Blynk app allows to create interfaces for our project, and Blynk server is responsible for all the communication between smartphone and PICSIMLAB. Next one is Arduino Uno. This is the board that we are using to implement our project. In this slide, we can see some components that we use to implement our project work. Those are LEDs, CLCD and LDR. In this slide also we are having the components such as temperature system, ETH W5500 Ethernet shield and serial tank. All of these spare parts can be found out in PICSIMLAB software. Now let's talk about the requirements of the project. We are going to control garden lights, the temperature system and water tank. In order to control these things at home, these things need to be connected to a microcontroller. As the controller board, here we use Arduino Uno board. In order to control these peripherals remotely, we are using a mobile application called Blynk IoT app, which is controlled by the Blynk server. In this project, we are automating three things. Garden lights control. Here we are using LEDs as our garden lights. This is functioned on LDR sensor. The intensity of light depends on the amount of sunlight received. When there is less light at night, the resistance is high, so the voltage is less. So the garden lights should turn on. When there is more light in the day, the resistance is low, so the voltage is high and lights should turn on. Next, the temperature control system. It consists of heating resistor, LM35 temperature sensor and a cooler. Here we need to read the temperature from the temperature sensor and display it on CLCD and gauge widget in app. We can control the temperature by turning off and on the heater and cooler through the Blynk IoT mobile app. And also, if the temperature would rise about 35 degrees Celsius, the heater would turn off automatically and we'll receive a notification in our app showing that the heater is turned off. These are the requirement and process. Finally, water tank inlet and outlet valve control. Here we read the volume of water in the water tank and display it on CLCD and gauge widget in app. If the water level of tank goes below 2000 liters, we will receive a notification in our Blynk app saying that the water level is below 2000 liters and inlet valve is automatically turned on. And also we can use button widgets in Blynk app to turn on and off inlet and outlet valves. These are the requirements and process. Now let's see the project implementation. This is the structure of PICSIMLAB and these are the spare parts that we use. This is the CLCD with HD44780I2C and this is the Ethernet shield and this is the temperature control system and this is LDR and this is LEDs. First, let's control the garden lights. Here we use this slider to increase and decrease the resistance. As I said earlier, during the daytime resistance is low, so the LEDs are turned off. Here you can see that result. During the night time the resistance is high, so we can see that LED is turned on. When we are increasing the resistance, here you can see LEDs are turned on. When we decrease it, we can see LEDs are turned off. Okay, now let's control the temperature system. Here I'll control this using my Blynk IoT app and I have mirror screened my phone so you can see the interface. This is the tab 1 and here you can see two buttons for cooler and heater. Here we can use them to turn on and off the heater and also the cooler. And there is a gauge widget to show the temperature. Now it's showing 27.37, which is the room temperature. If I turn on the cooler, you can see the CLCD shows the cooler is on, and you can see my app also. We can turn off the cooler, then CLCD shows cooler off. If we turn on the heater, you can see the temperature is rising. If you turn off the heater, you can see that temperature is decreasing. And it will show it in CLCD like this. Now, if we turn on the heater again, you can see the temperature is rising. Now you can see as soon as the temperature rises above 35 degrees Celsius, heater gets turned off automatically and the temperature starts to decrease again. It will decrease till the room temperature, and also here you can see temperature is above 35 degrees Celsius, turning off the heater. This notification we are getting. Now let's control the inlet and outlet valves of the cereal tank. Okay, this is our cereal tank, and I have connected it to COM1 port. Let's switch to the tab 2 in our app. As you can see, there are two buttons to control inlet valve and outlet valve, and also there is a gauge widget to show the volume of the tank. Currently there is water in our tank, so if we switch on the inlet valve, you can see the CLCD and it shows that inlet flow on, and as soon as the tank is filled, the inlet flow is automatically off. If we switch on the outlet valve, the CLCD shows that outlet flow is on, and you can see the water volume is decreasing. As you can see, as soon as the volume decreases to 2000 liters, the inlet valve automatically turns on, and we can see a notification in our app. Water level is less than 2000, water inflow enabled. And also we can see those details in CLCD too. So this is all about this project. In this internship, I have learned basic IoT programming and worked on a wonderful project using this knowledge. So I would like to thank Emertxe Information Technologies for giving me this wonderful opportunity, and thank you all.